All right, we're taking a look at Chem 30 here, and we're talking about predicting precipitation. And I just want to go over this example here with the solution all on the screen so you can see everything all at once. I'm going to attempt to just go over it piece at a time. So if you can piece this together while you're studying here. So let me just go over what this question is, what the answer looks like in completion, and you have an idea of if you're on the right track or not. So when we're predicting the precipitation of a precipitate, in this question it says there's 10 mils of this concentration, 0.1 molar of silver nitrate solution, so it's dissolved in the solution. It's added to 90 mils of this concentration, 1 times 10 to the negative 10 molar of Ki solution. What is the possible precipitate, and may it form, that may form, and will that precipitate form? So this is the key. Will that precipitate form? All right, we'll get to that towards the end here. But first thing you want to do is you want to make a balanced chemical equation. Okay, so you want to complete this right here. Now the first part's going to be easy because you're given these in the question. So if they're dissolved into ions, the possible combinations that would result would be the silver and the iodide, AgI, and then the potassium and the nitrate, KNO3. So when you get to this point, you want to look at these possible products that may form, okay? And you want to use your chart, your solubility chart, to find out if either of these are insoluble at all. Well, nitrates with, alkali metals are always soluble, so that one's out of the picture. This one, silver iodide, these could be insoluble, so this one has a chance. So what we want to do is we want to check the KSP at room temperature. We have a KSP of silver iodide of 8.3 times 10 to the negative 17. So this is the one you're going to look up on a table or chart or in your book. And what that means is the product of the concentrations according to, this dissociation equation for silver iodide, product of the concentrations if, they're going to multiply to this at room temperature always. So if you have more of one, you're going to have less of the other one or whatever. They're going to multiply to this. So what we want to do in this question is compare a trial KSP to this published KSP to determine whether a precipitate will form. If the trial KSP is greater than this published KSP, we will have a precipitate. All right, so let's pop over here. And what we're going to want to do first, of course, is we're going to focus on this AgI. So I want to find out how many moles of Ag I have. So we want to go to this original substance. We know that we have 10 mils, so that is 0.01 liters. And the reason why we want to change it to liters is because this capital M, molar, is moles per liter. So we have to have volume in liters and concentration in moles per liter. So we multiply those, we're going to get number of moles. So here's your number of moles, 0.001 moles. Now that's of AgNO3. Well, this dissociates into a 1-to-1 ratio, so that means that we're going to have the exact same number moles of Ag plus. Okay, that's our first step right there. So we'll do the same thing for the Ki. So I have 90 milliliters, that's 0.09 liters, of 1 times 10 to the negative 10 molar Ki. Multiply those together, and this is what you get. You get 9 times 10 to the negative 12, and that's going to be moles of I minus, or I negative iodide, ion, okay? So moles aren't what we're looking for. Of course, we're looking for moles per liter. So we must use molarity here. And so what we're going to do is we're going to take first the moles of Ag, of silver ion, and we're going to divide by the number of liters that we have. So where do I get this from? Well, I get this from the fact that we have 10 mils plus 90 mils. So I have 100 milliliters of total solution. So that's why I use 100 milliliters or 0.1 liters. So when I divide the number of moles by the number of liters, I get 0.01 moles per liter of AgI. And then over here, I have my moles of I minus divided by that 0.1, and this is what I get here. So I have this, very important, and I have this, very important. Okay. Now for AgI, what you have to pay attention to is that the KSP expression for AgI is, because this is a 1-to-1 ratio, right? You get one Ag ion and one iodide ion when this splits up. So it's going to be the concentration of Ag plus to the power of 1 times concentration of I minus to the power of 1. So that's why I've just multiplied them there. So when you multiply this, this is the trial KSP right here. So this is trial KSP right here. 9 times 10 to the negative 13. And so you want to compare now this trial KSP with this published KSP right here. And of course, this is times 10 to the negative times 10 to the negative. So the larger number here is going to be, the smaller number here is going to be greater, right? 9 times 10 to the negative 13 is larger than 8 times 10 to the negative 17. That means there's a lot more zeros in front of this. So since the trial KSP is larger than the published KSP, then a precipitate is formed, or a precipitate forms. So that's the full answer to this question here. That's kind of question you're going to get on your test. And yeah, I hope that helps.